Boom.
Yeah.
Hello and welcome back to Calculus 2 for one last time. I know, that's it. It is the retaking. Okay. So for those who are not retaking the course, yeah, that's it. I mean, we lived through all of the lectures, chapter 6, 7, 8, 9, 10, and now it's time to put all of that on the final. Monday is the time when you come in, you show off, right, your skills, and then you leave, and that's it. Then I'll see you, most of you, in Calc 3. Yeah, but that's not... Anyway. So, as I mentioned, the material for the final are chapters 6, 7, 8, 9, 10. Now, you all remember that the final exam this year is a bit shorter than the previous years. So, because of the scheduling issues, therefore our final exam is scheduled to be hour and 50. In my opinion, belief, it looks more like having a 1 hour and 45 minutes objective time, right? Generally, I assign 10 problems with a replacement problem and allot for that hour 20 minutes. So my projection that your final exam to be, possible, the time frame, it's probably going to be either 12 or 13 questions rather than 15, 16 questions. So we are looking for, let's just say 12, maybe 13, but 12. No replacement, no quizzes, none of that stuff. The rule of RVCC in the math department is what? 50 on the final and more, right? So all of you with all hundreds in a row, 49 will really ruin your semester, all right? So you have to pass the final. We also talked about the grade D that is not transferable to any of the schools, and the grade D is also not the grade that you can progress to Calc 3. Only if the Calc 2 is end of your math career and you don't transfer, D is okay to stay and you can graduate the program, but you can't transfer it. So if you keep the D, graduate with D, and then you transfer out, that D will not transfer and you will have to take this class at 2K or 3K or 4K, whatever it costs, wherever you go. So you do not want to see the grade D. Work hard. You have 5 days. We're going to talk about distribution of these problems. I'll give you the list, but this is the number of problems per chapter. So we are looking probably at 3 problems in chapter 10 because that is the only chapter that was not tested at all. So 10.1, 10.2, 10.3, each section gets a problem. Number 9, it's going to be either 1 or 2 problems, depending. That's a power series. So I would say that the radius and interval of convergence is a guarantee. But then, again, converting something into power series, like the infamous problem 3 from your last exam, where you should collectively facepalm, is a possibility. So that's the power series. Then we have 10 tests in chapter 8. It's safe to assume about 4 problems or so on, like 1 on sequence and maybe 3 on series. So you have like an alternating series. You have, I don't need to put the root or ratio because root or ratio would be integral on convergence, right? So I have the comparisons, I have the integral tests, geometric ones, right? You know what the main players are, geometric. I mean, that must be on that one. That would be insane if that's not on it, right? That's that. Now we have a chapter 7 with integration. Here's another 4 on it. With this 4, what am I looking at? Well, you have to realize that your by parts is there, right? You also have to realize that you have the trig sub, right? Which kind of involves the trig ones. And we also have in that section the, I don't have to worry about improper integrals if I ask the integral test, right? If I ask integral test, that's the improper integrals, right? But you have a partial fraction decomposition. Why do I like partial fraction decomposition? Because I also teach differential equations, right? And it's there in inverse Laplace. This is something that you must know if you, and at least half of you are going to differential equations. So that's my personal vendetta, the partial fraction decomposition. We don't have to go with 7 variables, right? But at least 2 variables or 3 variables would be okay. So you at least show me that you know. So we are looking at by parts, we are looking at the trig sub, we are looking at partial fraction decomposition, and then that numerical integration, again, not that important. Other integration techniques, again, can't use that because of the, can't give you the table for integrals. Improper integrals, and improper integrals are going to be in the integral test if there is integral test. So, you know, I can say 3 to 4 problems in chapter 7. And then the rest, right? So we have 8, 9 so far. 3 questions from chapter 6, let's say. Well, you have area between 2 curves. You have the length of the curve. You have the surface area of revolution, right? These shell volumes, all of that stuff. So there has to be one of those volumes, whether it's a disk or a shell. That would be a shame not to have that, right? It was on your project as well, so come on. And then, I mean, area between 2 curves, that should be a gift problem technically, right? When you subtract 2 functions and you're done. Hyperbolic functions are also in chapter 6, like 610 is a hyperbolic functions. You haven't used those functions before, but they solve differential equations. You have to be proficient in hyperbolic functions as well as in trig, because in differential equations, if I write y double prime plus y and y double prime minus y, one of them is solved with trig, the one with the plus, and the other one with the minus is solved with the hyperbolics. They are both wave equations, right? One dimensional, but later you upgrade. So hyperbolic functions, again, for you guys pushing forward, right, are important. Now, I'm not asking you to go and memorize the identities and stuff like that, but you must know that integrals and derivatives of sine hyperbolic and cosine hyperbolic do not have minus signs, right? Yeah, they are very similar to trig. So some of those basic ideas, you must know the formula that defines cosine hyperbolic in terms of ease and sine hyperbolic in terms of ease. I mean, those things you are getting through Calc 2, so you have to know those kind of things. So we are looking at those questions. As I said, I'm looking at 12 to 13 problems, more than like 12. If you add all of this, right, it works out to be more. So there will be trimming, right? But I kind of have to put those 3 from chapter 10 there. Vast majority of you are going to Calc 3, more than half are going to my Calc 3 class. I'm not going to have a bad class. And without chapter 10, just don't sign up. I mean, it's very simple. Because 3/4 of the course, 3/4 of Calc 3 depends on knowing 3 sections from chapter 10. So you absolutely, that's your winter right there. His thing. That's your winter. You gotta know how to parametricize, you gotta know. I mean, obviously those of you are more vicious will venture into chapter 11 and take a look and so on. So so this is the final. It's going to be hour 50. Effectively, it's hour 45. Standard stuff, no graphing calculators, no bathroom walks and stuff like that. It is bring in some kind of sugar thing to keep you alive during those hour 45. And then, we'll put puppies and all that stuff, so we're all good. The meerkat will be present again, so don't despair. Meerkat was fun, right? So we'll add that. Maybe we'll put the Dark Vader or something just to say it's final, right? Yeah, definitely. If you have multiple, I know that some of you will have possibly even 3 exams on that day due to bad scheduling. There's nothing you can do about that. Going crazy and, between the exam and studying, no. Take a walk, take a nap, go to library, pass out or something. If you live close, pass in bed for some time. Don't sleep through the final, but the rest is more important than additional 15 minutes of you getting confused. You don't... Ryan, tell them that you don't run before your runs.
Oh yeah, I don't run.
There you go. He's a professional runner. I didn't know that, so now I know. And if he's going to run 100 miles, and apparently he wants to, he told me, he's not going to run a 10-mile practice and then go on the start line and then run the next 100. Don't do that. I mean, so don't do that for your exam either. Rest when your brain is fresh, right? I know it's in the evening and but if you can take a nap in the afternoon, it's going to be more valuable than you actually going through formulas and things. Because rested brain pulls out files faster. And if you studied over the course of a semester, as many of you have, those formulas will be accessible to you. If your brain is tired and you start cramming and putting stuff into it on top of it, when you show up on the final, it's going to be bad. Especially if it's your 3rd final in a day, or 2nd, or whatever the hell it is. So yeah. At the most I took was 4 finals in a day. I'm alive. I wanted to. So yeah.
How did it go though? You failed them all.
It was top notch. So, all engineering courses and linear on. Yeah. I have engineering from RG.
Oh, really? Yeah.
Static dynamics all.
I'll have to take the
circuits.
Okay. Oh yeah, right here.
Whoa.
I just wasn't thinking.
All right.
Making a lot of money today.
It's all for the meals. Batteries are out, so no, you have to unscrew the top.
Oh, that's
If it's gonna be a bill.
that's too much work.
Do you have any questions, concerns regarding the final before we go through more details?
Oh,
Yes.
you want this crappy dollar instead? I'll take my dollar back.
Is sine hyperbolic, cosine hyperbolic, derivatives, integrals,
What's that for?
tangents hyperbolic?
So wait, all we need to know though for hyperbolic is hyperbolic.
No, said you did one already. Two you're gonna do. Well, I say that us three we can split them.
So, there's reasons why people want to see my class.
Would you mind doing just half of those
Hi, now it's
Are you guys gonna study for it?
Worried about the finals.
I was asking like so are you guys
Yeah.
All right, let's talk about details. Since you guys have no questions, let's talk about details of the list, and then we'll work out some problems and then disappear into the night.
Get ready for the final, but
So,
I'll try. I'm not ready.
what are the most important concepts
Yeah.
that are about 100% certain for the final, right? So there will be area between two curves. And then we have volume of revolution. I think this is 6 to, I don't know if I'm going to hit everything. Length of the curve, 6.5. And then, it's being streamed and posted. And then we have another thing in chapter 6. We had physics, all right, and then well, hyperbolic. But do we have anything before hyperbolic? We have exponential functions, and yeah, it's so hyperbolics. 6.10. All right, then we are moving into chapter 7 already. We're talking by parts, which is 7.2. Trig sub, which is 7.4. But guys, this assumes 7.3, right? Because you need to be able to solve the trig integral, so 7.3 is there. 7.5 partial fraction. That's 7.5. 7.6 is other means, and then we had 7 numerics, and then we have also the improper integrals, which could be either standalone problem or they could be within the integral test. So they will show up somewhere in one way or another. So improper integrals. Is that 7.7 or 7.8? 7.8, thank you. And then differential equations, guys, you're going to have a whole course on differential equations, so All right, moving to chapter 8, definitely sequence. So now for a sequence, I mean, you are talking about the limit test, which is either convergent or divergent, right? That's it for a sequence. And then you have series. I can't because you can't see it. Just catch up and then you'll fill in the blanks. So for series, you're definitely talking about divergent series because that's the most fundamental test, right? Number 1. Number 2, geometric. Number 3, we have ratio. Number 4 is the root. Number 5 is the integral with the P series. And then you have comparison, again with the P series. And then you have alternating. So that would be, now you don't see telescoping there. It's not a major thing. Telescoping, you know, they show up. And then you also, you don't see the, you know, comparison being offered as 2 tests. Generally, you know that we use limit most of the time, right? You see P series embedded in comparison and integral because whatever is the P series can be done by integral test. I heard that. So yeah. So we kind of narrowed the 10 tests down to 7, but still. I am missing something there. Root ratio. What am I missing? That's an alternating. Yeah, make sure that there were some issues with your exam. Yeah. That's the last one. So splitting this would make it 8, and telescoping would make it a 9. Oh, in the P series. Okay, good. Then we are moving to power series. And for the power series, you need to know how to get the function to equal to summation of ck x to the k or whatever from 0 to infinity, right? And then interval plus radius of convergence, which was again root test. Well, ratio, I'll put ratio or root test. Generally those are the ones that we use. And then we're moving into chapter 10. We have parametric, equations, and parametric equations doesn't work over there. For parametric equations, you are looking to convert parametric into the function or function into parametric. So you're going to go f into, well, curve into parametric or parametric into the function. And then graph parametric. Or derivative of parametric, which is the easy one, right? Because for the derivative, your dy dx is simply dy dt divided by dx dt. Or if you're using thetas, dy d theta dx d theta. So that's easy. You're given two formulas, you differentiate each one and just divide them. And then we have polar coordinates. You are looking into conversion or graphing, which is where we did point and line and so on. And finally, calculus in polar coordinates. Should I say emphasis on integration? I don't know. Like integral. Right. This is the final exam. As you can see, this is about good 80% or 90%. We are missing physics. We are missing differential equations. We are missing word problems or with exponential stuff. We are missing surface area revolution. We are missing numerical integration. We are, yeah, other integrals are there. We're missing, we are probably missing about 7 or 8 sections of what we covered. So this is good 80%. Now I can't do all of this stuff, but then you cross-reference this list with the learning outcomes. Those are the 100% ones, right? learning outcomes are on page 2 of your syllabus. And your syllabus is uploaded online. Lines them. So cross-reference this list with the learning outcomes, and that gives you 100%, right, certainty of what's on the final. And then if you come up with 8 or 9 problems from there, the rest of the list gives you the rest of the problems. But when you cross-reference the two, you should actually come up with pretty much the entire final. Improper integrals, right? More likely to get the one with the evil vertical asymptote than the one that has infinity, right? If you have it as a definite integral. But I know vertical asymptotes are evil. Now, obviously, if you are solving the improper integral within integral test, well, that's, 0 to infinity, right? So it's clear, type 1. So some of the things are clear. Some of the things are, right? No extensive calculations, which means that if you are already on a page 3 solving one problem, you are definitely doing something wrong. This is not computational class. You should not be expecting a computation that it's a page long. So do not ask me for scrap paper. Do not ask me for additional pages and books and stuff like that. Technically, if you can solve it in half a page, you are doing something terribly wrong. Again, I will call you back to your previous exam with the power series, problem number 3. We have the collective facepalm across the board, apart from the 3 students who got it. And you all seen me do it in 3 lines because that's all it is, 3 lines. So don't try to reinvent the wheel, just go straight with the easiest solution possible. There is only one way to make that problem easier from what you had on a test. All right? There's only one way you can make that easier. There's no other way to make it easier. I can make it the same with the cosine, right? Or I can make it easier. Now, I'm really not going to ask you to go and memorize the power series expansion for ln of x plus 1, which is on the list, right? Even though hyperbolic ones are the same as the sine and cosine, except you have no alteration. It's very easy to memorize those, but yeah.
So basically, x, cosine, x, sine.
You have cosine, sine, sine hyperbolic, cosine hyperbolic e to the x. You have, and then 1 over 1 minus x is 1 plus x squared plus x. There's no, it looks the same as e to the x, except there's no denominators of any kind. You just go 1 plus x squared plus x cubed plus x, right? So it's very simple. But, I mean, you can memorize 7 of those from the list of 13, like this, 7. But again, it is not a major outcome of the class, and you are going to see that in your math educational career at RVCC one more time in chapter 3 for DifEqs, and then you're not going to see it unless you hit some higher end computer science classes, electrical engineering classes, special electrical engineering. Like that's when you're going to see power series and Fourier series like really pounded down. But mechanical engineers are going to stray away from it. Civil engineering, anything else, environmental, everything else strays. You will never see power series again, most likely. Again, but electrical engineering, hey, hello, I know, look at that, they're all smiling over there. Power series for life. We're doomed. All right. Again, way too many of you, right, are going into Calc 3, so I want to see that chapter 10 on point, because I don't want to be teaching chapter 10 again. I'll be studying in one grade. Of course, I know you will. I just need to make sure that the others have the same attitude. And I think that's it. Do you have any questions, concerns regarding this list? Do I need to clarify anything? Yes?
I think I already said it, but what do we know about what do we need to know about hyperbolic functions?
So hyperbolic functions, you need to know the formula that takes the defines sine hyperbolic as e to the x minus e to the minus x over 2, one for the cosine hyperbolic, and then you need to know the derivatives and integrals of them, so you can.
But just the cosine and sine?
Well, the integrals are the same as the trig ones, so you can. So all 6 for calculus portion, but you don't have to worry about identities. You don't have to worry about all of that stuff. All right. So hyperbolic. Now, if there is a question with identities, or like it was on exam 1, I will give you the identity, and then you are responsible to know the E forms and just grind through algebra. I mean, it's the same deal like exam 1. You can go back and watch exam 1 review for more details on that, but technically whatever I said there still holds. I can't make it worse because we didn't cover anything after that, anything extra. That's it. So the worst it can be is whatever I have in the exam 1 review. That's technically it. Anything else regarding the final? So for integration, okay, now let's talk about the whole course and put everything into perspective, guys. So starting from techniques, right? Hopefully you figure out by now that half of the course is integration and half of the course is limits, right? Now, we have occasional derivative here and there. Derivatives showed up in the formula for arc length. Derivatives showed up for power series computation. Derivatives showed up in L'Hopital's rule. But the split is probably 40, 40, and then 20 on limits, or maybe even less. For 20% for the derivatives, I meant. Classification, extremely important. So when you see an integral, you go, do I see trig functions? Yes. Oh, it's a trig integral, right? Employ the trig integral procedures. What are those? Well, obviously U sub stands the first, and then the trig identity is the second, if the first one fails. If we see the square root of x squared, blah, 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 what do we check for first? Do we immediately go trig sub? No. What do we check first? U sub. Yeah. You check U sub for, yeah, you know what I did on a second exam. Wasn't there another one of those mass face palms, right? Where the problem was a basic U sub and all of you had the elaborate one-page calculation on something that was, again, 2 lines. So you have to understand, guys, every derivative you ever took in your life, you subconsciously, because you know it so well by now, I hope, you subconsciously are looking for chain rule first. Then you go and say, oh no, this was a product rule, or, you know, something esoteric after that. But you are kind of conditioned to look for the chain rule first because most of the derivatives you ever took in your life are chain rule. Well, for integration, what's the backwards chain rule? It's a U sub. And I understand that's a Calc 1 concept. But still, most of our integration techniques were massaging the integral in such a way that we can use U sub eventually, like partial fraction decomposition and everything else. So be very mindful of that U sub because, again, it's much easier than anything else we did in Calc 2. It's very frequent, right? And it's necessary. So that's the 5-5 from previous course. By parts, again. So make sure that by parts is okay. That you can do that. So so integral of tangent x dx is clearly U sub because you write sine over cosine. Cosine is u, and you go and you figure out. So integral of tangent x dx is clearly u sub question. But integral of tangent inverse, right? Is there a way for you to do the tangent inverse for the integration? Hell no. Can you differentiate it? Yeah, you can. So tangent inverse is clearly by parts, because you will be differentiating tangent inverse and you're integrating dx, right? So you have to be careful about that kind of stuff. Right? Something that it's near, it's not there, well, it's not there. You have to use the appropriate technique. So when you're classifying these things, you always want to try the cheapest and the most frequent thing first, which is by parts. By u sub. And then you go by parts and other things. Same goes sequences in series. You want to do the divergence test first, because that might knock out, one out of 3 questions. Instant. And then you go with the rest of the stuff. So you're trying to find ways to make the test shorter, right? By using the techniques that are more likely to be present on the exam. There's no way that I can make the exam for Calc 2 avoiding u sub. I mean, that would be insane to think of, right? I can't avoid addition. That's something you haven't learned in this course, right? You know it from before. So you should be assuming all of the knowledge from Calc 1 as well. I'm not going to have, question-related rates, right? The word problem. But can I address it in Calc 2? Sure I can, right? I will not. Power series, right? You have the interval and radius of convergence almost guaranteed to have the question on that, right? You want that root and ratio test most of the time, like 90% ratio test and then 10% root test for that one. Yes?
Would you give anything like Taylor expand not a trig function?
Well, it would be a basic function in that case.
Yeah.
Remember, you don't have 2 hours, you don't have 4 hours, you don't have, right? So, I mean, in all of their infinite wisdom, they moved my Calc 1 from Saturday to Thursday and gave me a slot from 5:30 to 9:40. Yeah, they get 4 hours for their final exam. Their final exam has 107 questions now. I need to add 3 more and we're good to go. 4 hours. I mean, it's obviously glitch in, it's going to be the same length as yours. I mean, I don't, department, but still.
Wait, is theirs this Saturday? Or next Saturday?
Oh, it's this Thursday.
Next Thursday, pay attention.
No,
Their review is this Saturday. I have a wonderful 5-hour review. Okay, so I think we took care of that. Anything else that we need to address?
very important.
I can't. So just look for the most direct way to solve the problem. Try not to be esoteric, and definitely don't make up any math. And some of you who did your exam 3 with series by looking at the growth rates, that doesn't work like 99% of the time. The rates within the series, and you cannot say, because consider this, guys. Yeah, we know that the summation of 1 over n as n goes to 1 to infinity is what does what? Diverges by p series or integral test, right? It's a harmonic series. It's a very well-known divergent, right? Divergent series. You can do the proof by integral test. We also know by p series, so we can say by p series or integral test, right? This is my last cry, so you realize that you cannot go and say, oh yeah, this is constant, this is faster, so slow over fast, yeah, this is going to converge. It doesn't, right? If you have one counterexample to what you think is true, what you think is true doesn't hold up, all right? So we have appropriate tests. Just use them, right? I asked you the day one, retire your common sense, okay? Because every bit of common sense says that this should converge, right? And it doesn't. So retire it, right? You know what the P series say. The next, right, is 1 over n squared, and that one converges, right? Yay, we're happy. Now, your common sense apparently works in one case and it doesn't work in the other case. Well, welcome to discrete part of the math. So brush up on those tests. Make sure that you are using root and ratio. I hope you went to SI and saw the solution to the exam and filled in the blanks where you have the blanks. I know I still need to fix the grade. And technically that's it. All right? That's it. At this point on, do you have any questions that are problems that you would like to see solved in detail from the list? Stuff that it's been on a previous exam, stuff that it's on their homework, stuff you dreamt of, your problem later. Yeah.
I got one.
You got one? Okay, let's see what you got.
I think didn't give any limits, so you have to set them equal to each other.
Y equals secant squared. Just make sure you are quiet because we are working the serious stuff over here.
No, 6.2, right?
I'm sorry?
The section 6.2?
6. So this is one of those questions where we have so this is a 6.2 area between two curves. The limits of integration are not given, and you have to solve these equations somehow. So the way we do this, both in 6.2 and in polar coordinates, which is 10.3, you have to set these two equations equal to each other and come up with the two numbers that will be a lower limit and the upper limit for the integral. So now I have secant squared x over 2 is equal to 2 cosine squared x. Now, to deal with this, I am going to multiply both sides by 2 first to cancel the 2 in the denominator. And that gives me secant squared x equals to 4 cosine squared x. Now, very important thing for solving these equations that have squares all over the place is to take the square root of both sides and remember to put plus minus when you square root both sides. So you don't get to put plus minus if you have just square root of 16. That's just 4. But if you have x squared equals 16 and you are square rooting both sides, then you have to put plus minus and you get x equals plus minus 4. So these are two different worlds. World of computation, square root of 16 is 4 and it's the end of story. But if you're solving equation and you square root both sides, you must put plus minus. So if I am to square root both sides, I'm going to put plus minus for this one. And what I'm getting is that the secant x is equal to plus minus 2 cosine x. Now, secant x is 1 over cosine x. Only one side gets it, so whatever side you pick, you can, if you like that side better for whatever reason. And I'm going to now multiply both sides by cosine x. And we are going to get that 1 is equal to plus minus 2 cosine squared x. Now, cosine squared x, that's great. I'm going to divide. So I'm going to take another square root to kill the square. But look what's happening now, guys. As I do this, I have to put another plus minus. Well, actually, I can put plus minus here now. I can't really use the negative, right? Because that will give me complex values. So this is where this minus drops. And what I have is plus minus 1 is equal to square root of 2 times cosine x. Now this square root jumps to the other side, becomes plus minus 1 over root 2 equals cosine x. So now the question is, when is cosine x equal to? Well, if you rationalize, right, you're getting cosine x is equal to plus minus root 2 over 2. Right? Now, what do I have in my unit circle? In my unit circle, when I look at this, cosine, all students take calculus. Cosine is positive in the first and the fourth quadrant. So cosine x equals root 2 over 2 is going to give me two values. X is pi over 4 and x is 7 pi over 4. So those are the two angles for a positive. And then cosine x equals negative root 2 over 2 is going to give me these two puppies. X equals 3 pi over 4 and 5 pi over 4. So we end up with 4 answers, and then you take a look at your graph, right, and determine which are the ones that you need. Most likely what you need are going to be actually pi over 4 and negative, pi over 4 and negative pi over 4. I can somewhat sense that those are the two that you need for whatever the problem you're working on, but this is how you solve the equation. This is all PreCalc 2, section 3.5. No. PreCalc 2, solving trigonometric equations. I just can't remember the section. It's 5.5, I believe, actually. Something like 5.5 or maybe 4.5. It's somewhere in there. Probably 5.5 because 5.1 is identities. You learn identities and then sum and difference and then product to sum. 5.3. Yeah, it's. I think it's 5.5 in PreCalc 2 in the current Chili Pepper book. So yeah. Happy? Good. Any other questions, concerns regarding calculations problems?
The integral of arctan.
Which one? You know the rules for the review. I'll spray you.
Well, we got the integral of arctan as dx.
Okay. So the integral of tangent inverse x dx. So this one, I mean, there are no identities for inverse tangent. We know that. So, and you know the answer, right? So, what do we do for this question, right? How do we integrate this? Well, we use by parts, because I know I can differentiate this. That's okay, right? I can differentiate here and I can integrate here. Because I can't integrate this piece. And if I can't integrate it, that's game over. But the good part is that integration by parts allows for differentiation as well, right? So I am setting up u, which is going to be my tangent inverse x, and then my dv is dx. So the du now is 1 over 1 plus x squared, right? dx. and the v is just x. And then my arrow that helps me put the formula together. So this is x tangent inverse x minus the integral of x over 1 plus x squared dx. No coughing. So we ended up with this integral now. U sub, very good. You see? So this was a Calc 2 question, but U sub is necessary. So now U is equal to 1 plus x squared. Du is equal to 2x dx. I don't have a 2, so I'll fix that with a half and a 2. And now the whole thing works out to be x tangent inverse x minus 1/2 the integral of du over u. Yes. Now what is the integral of du over u? Yes, ln x. So I have minus 1/2 ln absolute value of u, which is 1 plus x squared, plus c, or minus 1. Oh, you want minus 2? Okay, minus 2 by popular demand. We can change it for the final, so minus 2. Okay. That's a third thank you in a row. Right, so we had Chris, we had Mark, now we have Sandrine here. So, right, you will not be forgetting those. Because now it's minus 2 instead of minus 1. So you won't be forgetting the plus c.
Gonna get cold for Christmas.
Happy? Anything else that you might be interested in?
How about example 3?
Yeah, what?
R equals
R squared equals?
9 sine 2.
Okay, so what?
Set the integral of the area.
No, area? Okay. Yeah. So simple. So R squared equals to this. Well, what is the formula that we are using for our... It's A equals integral from alpha to beta. There is a half in front. And then we have R squared. Well, it says f of theta squared d theta. But we know that R is f of theta. So technically, this integral is 1/2 integral alpha to beta of R squared d theta. So we already have R squared as 9 sine. So we just have 1/2 integral 0 to 2 pi for the entire shape. And then instead of R squared, I'm writing 9 sine 2 theta d theta, and I'm not squaring in addition because square is already matched, right? So now I have 1/2, sorry, that's 9/2. When you kick 9 out, integral of sine is a negative cosine theta over 2 from 0 to 2 pi. That's what I said. It's clearly 2 theta. It says right here. Just have to look. So we have negative 9/4 of cosine of 4 pi minus cosine of 0. Now I factored out this negative sign, right? Did I? Maybe 1/2. Ooh. Don't we get a big fat 0 over here? Right? Do we? Yeah, we do. So we have to use the standard procedure, right? You have to actually graph this and figure out where to cut it and then double it or whatever. Yes?
R squared equals that equation. You also multiply everything by 5.
It's not a circle, so it doesn't work. R is a function, it changes.
What if it was a circle then?
Yeah. So we have to cut it. So this might be a little bit too spicy because it introduces 3 problems in one now. Right? There is a problem for area, there is a problem for graphing, there is a problem for right. But it will be needed. So once you graph this, and then again, graphing of this is going to be a little bit tricky. You have to graph, because you have to take a square root of both sides, right? Because you have to get R. Your calculator is R1, R2, R3, right? So it's R equals stuff for your calculator. So you square root both sides, you're going to get plus minus 3 root sine. So you have one line on your calculator will say positive root, right? Well, 3 root sine, and then one is negative 3 root sine. And then those two curves will give you the entire shape. And then you have to see which way it is. The long story short, yes. Summarize it.
That's not that long.
But, oh, that one summary. That's pretty good. So you can go further with, yeah, we'll do that. But that's what pushing is going to do. There's actually no. Anything else that you might be interested in? Oh, look at that. Time flies when you're having fun, right? I know. 15 hours fine. Well, by all means, we should leave now.
You want to stream it?
Yeah, I can stream. Strike it. All right, any other questions, concerns? Or we're going to end this party. So one more thing is you will watch all the previous exam reviews, the videos, and then dial it down a notch, right? You will go through all of the exams, dial it down a notch, and then it's a lot of material, but there is a reason why you are 1%. And when you beat this class, you become 0.5% in this school. 0.5% in this school. That's what you will be. So, you know, work hard for your status. I mean, that's what you do. Man. Well, you'll be surprised. The dropout rate and everything else.
Well, by show of hands, who's going to be taking this next semester?
By show of hands, who's taking this next semester? See if you can. My classes are anomaly. There's a reason for it.
What's your best rate?
Generally in 80s and 90s. I never had 100%. I did have a 75 failure rate.
That's pretty cool.
Yeah.
That's pretty bad.
25% pass, 75% fail. Was algebra.
Algebra?
Yeah.
Is it a college or
2 out of 100.
What?
2. Yeah. Let me show you. 1, 2. Out of 100. Yes. It's a partial credit on the first page and 3 pages for it.
One professor said that every single person who got to fail the class, he got an extra $50 from the department. So, so that was his goal. Make sure you do money.
All right. All right. All right. Let me give you 1 second. All right. Any other questions, concerns? Let's go. All right. Oh, hell no. Can I end the stream or? Okay, so then let's talk about the. Actually, no, we have nothing to talk about.